Welcome to this video from Derby Physics Tuition, and I've been working with an A-level physics student, and currently he's studying the thermal physics part of the course. So I'd imagine that if you're in year 13 studying A-level physics, that you will be studying thermal physics at the moment, so this may well be pertinent to you in terms of what you are studying currently. So let's have a look at this question. Quite a tricky one. 5 marks for this calculation, and quite a lot of work to do to get to the right answer. So a football is inflated when the temperature is 19 degrees Celsius. The inflated mass of the air inside the ball is 12.4 grams, and the circumference of the ball is 700 millimeters. We're going to assume that the air behaves as an ideal gas, and we can ignore the thickness of the material used for the ball. Calculate the pressure of the air inside the inflated ball. So we're told the molar mass of air as well, 29 grams per mole. So where do we start here? Okay, so I'm just going to work through the question here, and as I said, there's 5 marks. So quite a lot of work to do. Now, the first thing is to figure out what equation you actually need. And we're trying to calculate the pressure of the ball. And the equation we actually need here is PV equals nRT. Okay, so we're trying to calculate the pressure. Now we know what the temperature of the air is inside the ball because we're given that's 19 degrees Celsius, but we need to change that to Kelvin. So the temperature is 273 plus 19, which is 292 Kelvin. Okay, and you actually get a mark for changing the temperature into Kelvin. Now we know, so we've got T. Okay, R is the gas constant, which is equal to 8.31. Okay, so we've got that would come from the data book. And N, now N is the number of moles, and we're told that the mass of air inside the ball is 12.4 grams, and we're told that the mass of 1 mole of air is 29 grams per mole. So how many moles have we got? Okay, we can calculate that by doing 12.4 divided by 29, which will give us 0.428 moles. Okay, so we've got N as well. So we just need to use the rest of the information to find the volume, and you have to go through a couple of stages to get to volume here. So if it's a football, first of all, it's going to be a sphere, and the volume of a sphere is 4/3 pi r cubed, where r is the radius of the ball. And we're not given the radius directly, we're given the circumference. Now you know that the circumference of a circle is equal to 2 pi r, and so the radius will be equal to the circumference over 2 pi. So we now can get the radius of the ball. So the circumference is given as 700 millimeters. Now we've got to change that to meters. So that will be 700 times 10 to minus 3 divided by 2 pi. Okay, and that will give a radius of 0.111 meters cubed. Okay, so we can now work out the volume 4/3 pi r cubed. Okay, and if we put the numbers in with the radius that we've just calculated, we get 0.006 meters cubed. So we now have the volume. Okay, so we've got everything that we need to calculate the pressure of the air inside the ball. We've had to work out the temperature, which is pretty straightforward, the number of moles, okay, and then one or two stages to actually get to the volume of the ball. So if we rearrange that equation, we've got that pressure equals nRT divided by the volume. So that's 0.428 times 8.31 times the temperature, 292, divided by the volume that we have just calculated, which gives you a final answer of 1.73 times 10 to the 5 pascals. Okay, and just as a matter of interest, the maximum pressure of a football that can be used in Premier League matches, for example, is 2.1 times 10 to the 5 pascals. So that is a legal ball, and the circumference of the ball in this question is also legal as well. So if you do have any comments or any questions, do leave them in the comments section below, and thank you very much.